Okay, we're looking at equations of lines here, and you should know that all equations of lines are in the form y equals mx plus c, where m is the gradient, and c is the y-intercept. Alright, so where it crosses the y-axis, and the gradient is the slope. So, if we look at this first one, okay, the gradient, it says find the gradient. Alright, so gradient of the first one is the coefficient, the number with x, so that's 5, nice and easy. Y-intercept is 3, minus 3. Now if you put 0 minus 3, that is actually the coordinate, it crosses the y-axis, isn't it? And if you look at the second one, it's not quite in the right form, so what I need to do is rearrange this to get it into the right form. I'm going to actually do it like this. I take x away from both sides, then I divide by 3. Okay, and then we get the gradient equals the coefficient of x minus a third, and the y-intercept is 3 or 0, 3. Okay, now then, the reason I've been saving red and blue is because I'm going to do these here. So, with this one, we're going to plot it. So, y equals 3x minus 2. First thing I need to do is plot minus 2. So that's where we're crossing the y-axis. Now, the gradient is worked out. So the gradient is worked out by doing the rise over the run. Rise over run. So if it's 3, okay, that means it goes up 3 and along 1. Rise over the run. So I go up 3 along 1, up 3 along 1, up 3 along 1. There we go. Up 3 along 1, up 3 along 1, and I'm going to now draw a line. Okay, now then, with this one, again, we're not quite in the right form, right, so I'm going to do, I need to divide everything by 2, don't I? So we've got a half x plus 4, okay, so here we go, 4. And this is already in rise over run. So up 1 along 2, up 1 along 2, up 1 along 2, up 1 along 2, up 1 up. Okay, here we go. I'm going to go back this way as well. And there we go. Now, if you had a negative gradient, you got your down however many along one, along however many, alright? So a negative gradient, you're going down. But other than that, it's no different.